Hello everyone, I'm Farhad. Following our last class, we are going to prove logically our first theorem based on circle. The statement of our theorem 1 is the line segment joining the center of a circle to the midpoint of a chord other than diameter is perpendicular to the chord. The line segment. How to find the line segment? To find the or to have the line segment, we have to join 2 points. One is the center of the circle, and the second point is the midpoint of a chord. But that chord can be a diameter. The chord can't be a diameter. We have to choose the chord in such a way that it can't be a diameter. The line segment joining the center of a circle to the midpoint of a chord is perpendicular to the chord. You have to prove that the line segment is perpendicular to the chord. Let me demonstrate the statement. This is our circle. This is our fixed point. This is the fixed point of the circle, and we name it O. Here I have taken a chord AB, which isn't a diameter. Why can't we tell the chord a diameter? Because the chord isn't passing through the center. We can call a chord a diameter only when the chord is passing through the center. Now we have to take the midpoint. We have to take the midpoint of the chord AB, because for the line segment that is stated in the statement is the line segment joining the 2 points. One is the center of the circle and another is the midpoint of the chord. So we have the center. Now we have to find the midpoint of a chord. Now I'm trying to find the midpoint of that chord in geometric way. Well, we have our midpoint of the chord AB. Our next step is join the 2 points. One is center, another is midpoint, and I have joined the 2 points. And this is our stated line segment. This one is our stated line segment. What we have to prove? We have to prove is the line segment is perpendicular to the chord. This line segment is perpendicular to this chord. That means this perpendicular is creating an angle of 90 degree with this chord. This is 90 degree and also this one. We have to prove this. We have to prove this logically that this is 90 degree. Well, let's name the point of the midpoint of the chord AB, B, D, and let's take an arbitrary point on the circle. Let this is C. Well, let A, B, C, let A, B, C a circle and O be the center, O be the center of the circle. Let ABC be a circle and O be the center of the circle. OD is the line segment. OD is the line segment joining the midpoint of the chord AB and the center O. We have to prove that. We have to prove that OD, line segment OD, is perpendicular to AB. We have to prove that OD is perpendicular to AB. I've turned over a new page. So since I can't see the diagram in this page, since I can't see the diagram in my new page, for my convenience, I will draw the same or exact diagram on my new page for my convenience. It will help me to prove easily the whole theorem, and it will save a lot of times. Otherwise, I'll have to turn over the page repeatedly for every single step. To avoid this, I'm drawing the diagram again on my new page. What we name the circle? A, B, C, and this is our circle. We named it O, and we have it called AB. We have it called AB, and this is our midpoint of AB, and I'm joining the 2 point O and D be the midpoint of AB. Now there is construction that will help us to prove that theorem. What is the construction? We have to add more 2 points. One is O and A. We have to add O and A. We have to add O and A to find the line segment OA. And we also have to add O and B to have the line segment OB. This is our construction in this theorem. Add O comma A and O comma B. Add O comma A and O comma B. Well, now we are going to prove the theorem step by step. It's not a tough one, it's a easy one. Okay, in our diagram, if you see carefully, we have two triangles. One is ADO, and another is BDO. In our diagram, we have total 3 diagrams. One is ADO, one is BDO, and another is ABO. But we will fix our eyes only on 2 triangles. One is ADO, another is BDO. So in triangle ADO and triangle BDO, and triangle BDO, we can write AO is equal BO. AO is equal BO. In this 2 triangle, AO is equal BO. This line is equal to this line. Why? Because in the definition of the chord, we have seen that to have to be a circle, there have to be a fixed distance between the moving point and the fixed point, and we call that fixed distance is radius. This is the radius of the circle, and this also the radius of the circle. AO is the radius of the circle. BO is also the radius of the circle. Since the radius is fixed for a particular circle, so we can say for this circle, AO is equal to BO. AO is equal to BO. In third bracket, we can write radius. In short, we can say radius. Okay. We can say what? Radius. Since AO and BO are the radius of the circle, so both of them are equal. in length. Well then, see, in the triangle ADO and in the triangle BDO, there is common length, there is a common side. DO is a common side. DO side is in triangle ADO. DO side is also in triangle BDO. So we can say DO is equal to DO. We can say in that bracket common side. We can say common side. Okay. And there is another side that we can examine, that is AD of triangle ADO and BD of triangle BDO. Since D is the midpoint, of AB, since D is the midpoint, what kind of point? Midpoint. Since D is the midpoint of AB, so we can say AD is equal to BD. AD is equal to BD, and AD side is in triangle ADO and BD side is in triangle BDO. So you can write, or we can say AD is equal to BD since D is the midpoint of AB. Well, in this two triangle, we have proven that, we have shown that three sides of this triangle is equal to the three sides of this triangle. If you can remember the theorem that you have learned in your class 7, there is a theorem in class 7, we call it SSS theorem. We call it SSS theorem, side theorem. What is the theorem? What is the theorem? The statement of the theorem is, if three sides of a triangle is equal to any three sides of another triangle, we can say both of the triangle are congruent to each other. I'm writing down the statement. If three sides of a triangle is equal to the three sides of another triangle, then both the triangles are congruent to each other. In short, we can say the theorem as SSS theorem, side theorem, in short. Since we have shown that three sides of the triangle is equal to the three sides of the triangle, so these two triangles are congruent to each other. We write this mathematically or symbolically in this way. Triangle ADO is congruence to triangle BDO. Triangle ADO is congruent to triangle BDO. Well, what does the congruence means between the two triangles? What does the congruence mean between the two triangles? If two triangles are congruent to each other, then three sides of the triangle is equal to the three sides of another triangle, and three angle of a triangle is equal to the three angle of another triangle. Well, let me show you what congruence means in this part. Let we have two triangle, one is ABC, another is DEF. We have two triangle, one is ABC, another is DEF. If these two triangles are congruent to each other, then we can say this side is equal to this side, this side is equal to this side, this side is equal to this side. That means AB is equal to DE, AC is equal to DF, and BC is equal to EF. Well, now we will focus on the angles of the two triangles. Since these two triangles are congruent to each other, so we can say three angles of this triangle is equal to the three angles of this triangle. So you can say angle cone is equal to angle A, angle A is equal to angle D, angle A is equal to angle D, angle B is equal to angle E, angle B is equal to angle E, and angle C is equal to angle F. This is what congruence means between two triangles. Okay, sides are equal and angles are also equal. Since in our theorem we have proved that triangle ADO, this triangle, and triangle BDO, this one, BDO, are congruent to each other, so their angles are also equal. Since these two triangles are congruent to each other, so their angles are also equal. So we can say angle ADO, this angle is equal to angle BDO, this one, angle BDO. Angle ADO is equal to angle BDO. We will only focus on this two angle we don't need other two angles, because in this theorem we only need this triangle. So we won't focus on other triangles. We only focus on these two triangles. Angle ADO is equal to angle BDO, since these two triangles are congruent to each other. Well, in our diagram we can see that chord AB is a straight line. Chord AB is a straight line. Here chord AB is a straight line. Here chord AB is a straight line, and we know any point on any straight line, any point on a straight line creates an angle of 180 degree. That means, let me show this here separately. This is a straight line, and I have taken a point on that straight line. Since every point on a straight line creates an angle of 180 degree, that means this point on this straight line creates an angle of 180 degree. Okay, so in our diagram we can see that the chord AB is a straight line, and D is a point on the straight line. AB is a straight line and D is a point on that straight line. So we can say there is an angle 180 degree at point D. We can say there is an angle of 180 degree at that point on that straight line. So you can write angle ADO, this angle ADO is equal to 180 degree. This is our chord AB, and this is the point D. So when our angle looks like this, as this is A, this is D, this is B. How do you write the angle? Obviously, you write the angle in this way: angle ADB. Angle ADB. Obviously, in this way, ADB. Now, if I place this point A in a way that I'm drawing, B point is here, this D point is here, and this A point is now here. This A point is now here. So in our first diagram, the angle was this, and now the angle is this. Similarly, the way we write the angle ADB, the exact way we write this angle ADB. Hope you have understood. So on our chord AB, there is a point D. So we have an angle of 180 degree at that point D on the straight line AB. I have write it in this way. Angle ADB is equal to 180 degree. Now, in our diagram, let's draw this diagram here again. This is our chord AB. This is our chord AB, and this is center O, and this is the midpoint D. This is the midpoint D. So I have written that angle ADO, that means this angle is equal to 180 degree. This angle ADB, this is not BO, this is B. Apologize for my mistake. ADB. This angle is 180 degree. Now, if I divide this angle, by a straight line, that this straight line is OD. Now I have divided this angle by a straight line OD. So this angle is consist of two angles. Now this total angle is consist of two angles. One is this and another is this one. One is this and another is this. If we add these two angles, we have the total angle. So instead of angle ADB, we can write angle ADO plus angle BDO. See, angle ADO plus angle BDO. So this total angle ADB is consist of these two angle. That's why I have written angle ADO plus angle BDO instead of angle ADB is equal to 180 degree. Well, we have here two angles. One is angle ADO and another is angle BDO. Earlier we have proven that angle ADO is equal to angle BDO. Angle ADO is equal to angle BDO. See, angle ADO, angle BDO. Angle ADO, angle BDO. We have proven earlier that these two angles are equal to each other. So angle ADO plus angle, now instead of angle BDO, we can write angle ADO. Instead of angle BDO, we can write angle ADO. Why? How can we write this? Because we have earlier proven that these two angles are equal. So we can write N1 in other place when we need to put this. So we can write angle BDO is equal to angle ADO. We have written angle ADO instead of angle BDO since these two angles are equal, is equal to 180 degree. Or angle ADO plus angle ADO. See, these two angles are same. Now these two angles are same. So angle ADO plus angle ADO, we can write 2 and ADO is equal to 180 degree. Let this is A, let this is A. Then A plus A, we can write 2A. Let this is A, suppose this is A and this is A. So you can write A plus A is equal to 2A. Here A is not A, here A is equal angle ADO. So angle ADO plus angle ADO, we can write 2 angle ADO. Now, if we divide the both sides by 2, if we divide the both sides by 2, this 2 will be cancelled out and we will divide 180 degree by 2. Or angle ADO, where is the 2? Since we have divided the last line by 2, the 2 was cancelled out, and on the right hand side 180 divided by 2, and if we divided 180 by 2, it will be 90 degree. It will be 90 degree. So if I draw the diagram again, this is our circle, this is our chord AB, this is our center O, and this is the midpoint of the chord AB, and we have joined the 2 points OD. Now see, we have proven that angle ADO, which angle? Angle ADO, angle ADO, angle ADO is equal to 90 degree. That means this is 90 degree. So we can say this line or this line segment has created an angle of 90 degree with the chord AB. That means the line segment OD is perpendicular to the chord AB. That is the point the statement of the theorem has asked us to prove, and we have proven that. So we can write, so OD is perpendicular to the chord AB, and this is what we have to prove, and we have proven that logically, and this is the end of this theorem. This is proven. Hope you have understood the whole process. See the video repeatedly if you don't understand. You won't understand this theorem at the first view. See it repeatedly and carefully. Always try to prove any geometric problem step by step with the help of diagram. It will be a lot easier for you if you prove every single line following the diagram. Don't ever try to memorize what to say that word. Okay, I can't remember that word right now. Always try to prove any geometric problem line by line, step by step with the help of diagram. It will be more easier. It will be more convenient for you to understand the whole process. That's all for today. In our next class, we will focus on some exercise given on 10.1. Till then, stay safe, stay happy. Allah Hafiz.